right, now we're combining. Combining is adding or subtracting. Take a look at this. It says, combine and express your answer in simplest form. Well, I can do that quite easily because we have the same denominator. If we have the same denominator, all we do is combine the numerators. So we have 7x plus 11x, which is 18x over 9y. Now here's the deal. Whenever we have fractions, when we're done combining, multiplying, whatever, we want to reduce it. Well, we can reduce this. And the reason we can reduce it is because these are factors. So 9 goes into 9 once, 9 goes into 18 twice, and we get 2x over y. That is my final answer. Now, that's just problem 1 off that part of the problem. It says, explain why this works. Well, we know why it works because they're the same denominator. Remember, we can combine like terms. And remember, we talked about in Mod 4, we talked about the fact that with fractions, like terms meant the same denominator. Because remember, they were the same size piece. Okay? So this 9y piece is the same as this 9y piece. So I have 18 x's of those 9y pieces. Okay, that's what it said. And the other thing said, verify your answer by letting x equal 2 and y equals 5. Okay, so here we go. I'm going to plug it in up there first and then down here. So watch. I'm checking. 7x over 9y plus 11x over 9y. Okay, if I plug in these numbers in here, watch what happens. I get 7x is 7 times 2 over 9 times 5 plus 11 times 2 over 9 times 5, which is 14 over 45 plus 22 over 45, which I get 36 over 45, which can be reduced by 9. 9 goes into 36 4 times. 9 goes into 45 5 times. So my answer is 4/5. Now watch this. Here's what I got. 2x over y. 2x over y. That would be 2 times 2 over y is 5. See? Beautiful. That's what I've been trying to say all day. These little things that we get are equivalent. Now it asks us one more question. Is it true for all real numbers? What they're really asking me is, is this always going to be true no matter what we plug in for x and y? Can you think about why maybe it can't? Well, the denominator again. We cannot have y being 0, because if not y is 0, this is 9 times 0, which is 0, makes it undefined. So it's true for all real numbers except 0. So that's the answer to that question. So that's all the parts to that question. Now let's make this maybe a little harder. That was pretty easy, so we're going to continue with some more questions. Okay, let's take a look at this. Again, we luck out and they have the same denominator. So we know that we can do this. 4y is the denominator, and we get y squared plus 2y. Cannot combine y squared plus 2y, so that's the best we can do. So that's the first step, is combine the numerators, keep the denominators if you have the same denominator, and now you want to try to reduce it. Well, remember, we just learned how to reduce. We did multiplication, division, reducing. We have to have factors. So guess what we have to do? Yes, we have to factor it. So we're going to pull out a y and get y plus 2 all over 4y. And we're going to reduce. Good night. And we get y plus 2 over 4. That's our final answer. Y plus 2, oh, yep, over 4. Y plus 2 over 4. Done deal. Okay? Let's try this next problem. Okay, it's really kind of short. I just want to make a statement about it. It's 4x over x minus 2 minus 3x minus 2 over x minus 2. Okay. I think they're plus. Sorry about that. Plus 2's. Okay. I want to just take a look at this. I want to show you what we have. We have this. We have x plus 2 on the bottom, same denominator. Here's where you have to be careful, because technically, even though I didn't even do it here, it might have been healthier if I wrote parentheses in here. But you would have said, oh, why are you doing that? You don't need parentheses. But they're the separate things, that expressions that came off here. Here's why that might have been healthier. Okay, watch. If I did it here, Is it necessary here? It absolutely is necessary here because that -1, okay, is going to get distributed. So the whole deal is you have to be very careful because we're minusing this whole thing. So you need the parentheses. Well, when do you need the parentheses? You need the parentheses when there's a negative and it's followed by something bigger, an expression bigger than a monomial, meaning more than one term here. If there's more than one term, you're going to need that parentheses. So here's my thing. Maybe you should put it in all the time, and you'll see if you need it or not. Okay, that makes more sense so you don't get kind of lazy and lose sight of the fact when you need it. Okay, so let me finish this problem off. This is 4x minus 3x minus 2, plus 2, because I'm distributing a negative. Don't forget all the signs change, over x plus 2. That's x plus 2 over, oh, look, you're welcome. Okay, x plus 2 over x plus 2, good night, Irene. We get 1. Is this true for all real numbers? Are we always going to get 1? Well, not -2, because -2 will make this undefined. I'm not asking you that. That's freebies. Okay? However, the answer to this problem is 1. So no matter what we stick in for x, except for -2, no matter what we stick in for x, we're going to get a 1 back. That is an awesome, awesome problem. So just understand that you might want to use parentheses because sometimes you need them, especially when there's more than one term here followed by a minus sign. Okay? I'm going to let you try some problems, and then we'll get back. All right, let's take a look at how you did. Be careful about your parentheses. Okay, these had the same denominator, so I can leave that. And now on the top, I'm going to put parentheses in just to make sure we don't forget them. This is 2z minus 5. Of course, those were not necessary. That's okay. And I have 2z minus 5 over 10z squared. And I cannot do anything with that. You know why? Because I cannot factor the top. The bottom is already factored. I cannot factor the top. I am done deal. That was beautiful. So if you got that, awesome. Let's take a look at this one. Okay, we have the same denominator, 3 times the quantity x minus 2. And I'm going to put parentheses just so you understand when you need them, when you don't. You obviously don't need them here. You never need them with a plus, but that's okay. 8x plus x is 9x over 3 times the quantity x minus 2. I'm now going to reduce. Well, the top is factored, the bottom is factored, and I have common factors. 3 goes into 3 once, 3 goes into 9 3 times. So on the top, I have 3x. And on the bottom, I have the quantity x minus 2. And I cannot reduce these x's because this one is a term. You cannot reduce terms. Okay. Once last year, in the middle of my class, I actually wrote that on my forehead. You can't reduce terms, just to remind everybody. Okay, cannot reduce terms. Okay, so don't do it. I'm not wearing it today. Okay, let's look at number 3. Number 3, same denominator. 5x minus 2 plus 3x plus 2. Notice you don't need those parentheses. So this is just really 5x minus 2 plus 3x. I rewrote that because I keep telling you not to go straight from parentheses to your answer, so I can't do it either, right? 5x plus 3x is 8x. We get 8x over, because minus 2 plus 2 drops out, 4x plus 8. We are almost done, not quite. You know why we're not done? Because we can factor to reduce. So pull out a 4, we get x plus 2. Reduce. We get 2x over x plus 2. This is not the same. 2 multiplied by x, 2 plus x. Cannot reduce. Bottom has terms. Top has factors, but bottom has terms. You are done there. Awesome problem. Okay, you ready for the big guns? Here comes the big guns. 5x minus 10 is the same. So on the top, 10x plus 3 minus 5x minus 3. Okay? So now we absolutely need those because we're going to distribute this -1. It's going to change all the signs here. So we have, I'm going to write it up here, 10x plus 3 minus 5x plus 3 all over 5x minus 10. All right, so here we go. 10x minus 5x is 5x. Plus 3 is plus 6 over 5x minus 10. Now we try to reduce. In order to reduce, we have to factor. The bottom is factorable, but the top is not. No GCF. Two terms, but it's linear. Can't factor it. So I'm done right there. I can factor the bottom, but it doesn't help me. So why bother? Because I can't factor the top. So you're done right there. Okay, that's it with that section. Not the section. We have a couple more problems with, but at least with that screen. All right. Looks terrible, but it's really not because we have the same denominator. So that makes it really easy. Okay. Let's take a look at this one. X squared minus 1. All right. And we have x minus 1. Obviously, I don't need my parentheses. And on the bottom, I can factor that. It's the difference of two squares. And I always try to factor at the end because I want to try to reduce. X times x, 1 times 1, 1 plus, 1 minus. Good night. And we get 1 over x plus 1. That was a beauty. Okay? That was pretty easy. Wow. Huh? Looks terrible, but I swear it's really not. 2x squared plus 8x is my least common denominator. And I have 5x squared minus 12 minus 2x squared plus 7 plus 3 minus 2x squared. I know what you're thinking. You're thinking, why is she not getting a rash? I'm not getting a rash because I'm combining these. It doesn't matter what order they're on. Commutative property, baby. Okay, so I'm going to rewrite this because I should not try to go right to my answer from parentheses. I'm going to simplify this. I don't really need these parentheses. So it's 5x squared minus 12. Here, I'm going to have to distribute the negative. I'm going to get negative 2x squared minus 7. Here, I don't really need it. Plus 3 minus 2x squared all over 2. I love these because, you know why I love these? Because once you're done, you feel like you've done something. You're really cool because you get it right. Okay, so we have 5x squared minus 2x squared is 3x squared. Minus 2x squared is just plain x squared. Okay? And then we have minus 12 minus 7 is minus 19. Minus 19 plus 3 is minus 16. All over 2x squared plus 8x. You're thinking I'm done. I'm thinking you're not. Okay, here's why you're not. You're not done because I have to try to reduce this, and the only way to reduce this is to factor it. Yes, we did say factor it. You getting your drift here? If you can't factor, you pretty much can't do any more math. So you need to learn how to factor. Here we go. It's the difference of two squares. When there's two terms, we look for, you know what, I'm going to do it below there because it's getting ugly. Okay. When there's two terms, well, we look for a GCF no matter how many terms there are. There is none. We have standard form. Two terms we check for. Difference of two squares, and it is. So here we go. It's x plus 4, x minus 4. Take out a 2x, GCF. We get x plus 4. See? Winner, winner. Winner, winner. Good night. Good night. We get x minus 4 all over 2x. And we are done. Good night. Cannot reduce these. Here it's a factor. Here it's a term. One last thing. Is this true for all real numbers? Well, not for 0, because 0 would make x 0. And not for negative 4, because would you make that factor 0. That's a freebie. You didn't have to know that. But that's the answer. You are done. That takes care of this lesson.